Welcome to Algebra 2. This video is homework for Unit 2 problem set 3. Question 1 is asking you to prove that y-intercept for any factored form is basically this times this times this, and you will be doing that by converting to standard form. How do we do that? So you're given this. Imagine this doesn't exist for now. Okay, you have a times bx plus c. You can do that, right? It's abx plus ac. Now you bring in this dx plus e, right? And you can FOIL it out, like first term, outer term, inner term, and last term. You can distribute that. How would that look like? So you take this a bx, you multiply with dx plus e, and you take your plus ac and you times it by dx plus e, right? And now when you do that, you get a b d x square, that's that. ab plus e, times e, is a b e x. ac times dx is ac dx, plus ac times e is a times c times e. Here the constant term is a times c times e. That is also your y-intercept, right, in standard form. So if you think about that, you just proved it that y-intercept is product of a times c times e. The other way you can do it is by plugging 0 for x. How does that look like? Your equation right now is y equals a bx plus c times dx plus e. If you plug in 0, you get y equals a times b times 0 plus c times d times 0 plus e, right? This times b times 0 is 0, d times 0 is also 0, so it's product of a times c times e, which is also what we have here, right? Alright, moving on. For the following equations, determine the x-intercepts, y-intercept, degree, and leading coefficient. X-intercepts is what makes this 0, makes your factor 0, right? So your x-intercepts are negative 1/2 and 7. Your y-intercept, again we just proved it, right? It's product of 1, 1/2, and negative 7. So it's negative 7/2. That's your y-intercept. When you multiply 1 times 1/2 times negative 7, you get negative 7/2. The third is degree. How many factors are there? Here you have 1, here you have 2, so you have 2 factors. What is your leading coefficient? Leading coefficient is product of this, this, and this. So all those ones, so leading coefficient is 1 here. Okay, same thing here. X-intercept, this one is going to be 1/2, negative 3, and positive 2. Y-intercept is product of 1, negative 1, 3, and negative 2, and that is 2 times 3, which is 6. Y-intercept is 6. Degree is 3. There are 3 factors, 1, 2, and 3, so degree is 3. Leading coefficient is product of 1, 2, 1, 1, so it's 2. Okay, what do I mean by leading coefficient? Let's talk about that. Here, what is the leading number in the entire equation? The number that's leading is going to be up here, and it's 1. What is the leading term here? 2. What is the leading term here? 1. What is the leading term here? 1. So you got 1 times 2 times 1 times 1. So leading coefficient is 2. X-intercept for this ones are negative 4, 1, and negative 5. Y-intercept is product of negative 2 times 4 times negative 1 times 5. What is that? 5 times, so this becomes positive, so this is positive answer. 2 times 4 is 8, 8 times 5 is 40. Degree is 3. Leading coefficient is product of negative 2 times 1 times 1 times 1. So it's negative 2. Cool. X-intercept, negative 1. This is 2/3. This is negative 4/5. Y-intercept is negative 4 times 4 is negative 16. Negative 16 times negative 2 is positive 32. Degree is 3. And leading coefficient is product of negative 4 times 1 times 3 times 5, which is negative 60. Cool. Given a polynomial with an x-intercept of negative 2 and negative 4, so your factors are x plus 2 and x plus 4. Run an equation that has y-intercept at negative 64. Right now, your y-intercept is at 8, because it's 2 times 4, which is 8. What can you multiply to 8 that gets you negative 64? And it is 8 times negative 8 is negative 64, so this is negative 8 times x plus 2 times x plus 4. That would be the answer. Alrighty, moving on. Write the following graph in factored form. You really cannot see, but it's negative 3, positive 1, positive 2. Those are your x-intercepts. So your factors are x plus 3, x minus 1, x minus 2. Your x-intercept is at negative 2. I mean y-intercept is at negative 2, right? Currently it's at positive 6. Y-intercept, if you leave it as it is, it's 3 times negative 1 times negative 2, which is positive 6. What can you multiply to positive 6 that gets you negative 2? Or a, let's say that. What can you multiply to 6 that gets you negative 2? And it's negative 1/3, so this is negative 1/3 times x plus 3 times x minus 1 times x minus 3. The end behavior of any polynomial is determined by its degree and leading coefficient. So degree you're looking for if it's odd or even. Leading coefficient you're looking for if it's positive or negative. Okay, they both tell you which direction it's going, right? So let's talk about this here. Question number 6. The degree is 2. Leading coefficient is positive 5, right? Positive 5. And behavior, I can think about it 2 different ways you can do. All you have to do is take the term with the highest degree. Here it's 5x squared, right? Plug in, say 100. Plug in 100, positive 100. You get 50000. This is positive, right? Plug in negative 100. You will also get the same answer as positive, right? If you just plug in here 5x squared, you get the same answer, right? So what are we saying? As x is increasing and increasing forever on the right side, I guess, as x is going towards positive infinity, going towards the right side, y is going towards positive infinity as well, because it's increasing up, right? It's positive, right? As x is going towards negative infinity, as you plug in negative 100, you got a positive answer again, right? Y is going towards positive infinity in the same way. So if I were to graph this, I'm not going to graph the entire graph just to show you the end behavior. I'm saying it's going up on both directions. It's going up in left and it's going right. It's going up as well. Okay, another example here. Degree is 3, leading coefficient is positive 1, and behavior. Plug in 100. You get 1 0 0 0 0 0 0. It's a positive number. That's what we care. Okay. Plug in negative 100. You get a negative number, right? So what can you tell me from here? We're saying as x is going towards the right, positive infinity, y is going towards positive infinity. As x is going towards negative infinity, y is going towards negative infinity, because you got a negative answer. That will be the end behavior. Degree here is 3, leading coefficient is negative 7, and then end behavior, plug in 100, you get negative 7 0 0 0 0 0 0. Yeah, it's negative, right? So it's negative. Plug in negative 100 and you get positive 7 0 0 0 0 0 0. So what can you conclude here? Here you're saying as x is going towards positive infinity, y is going towards negative infinity. As x is going towards negative infinity, y is going towards positive infinity, and that would look like this. Negative infinity is going up, positive infinity is going down. Here It's the opposite. It's going up, it's going down as you're going left. Okay? We'll talk about this during class as well, so you get a better idea of it. Question number 7. You're given a graph, you're telling me the degree, you're telling me the y-intercept, you're telling me the x-intercept, and you're telling me the factored form. Okay, so the first step to do that, to figure out the degree, is how many x-intercepts are happening, right? Here is one, here is the other one. But here, your graph is bouncing off, right? Here it's just going through, right? But here it's bouncing off. When that happens, this happens twice. So this happens once, this happens twice, and 1 plus twice is thrice, so degree is 3. Y-intercept is -2. So x-intercepts are 1, 2, -1, 2, and 2, because that happens twice, right? This happens twice, because it's bouncing off. Whenever it bounces off, it happens twice, okay? What is the factored form? Factored form is y equals a. You don't know what the a is, we're going to figure it out, right? A times x plus 1 times x minus 2 times x minus 2. How do you figure out the a? Where you look at the y-intercept. Right now, your y-intercept is 1 times -2 times -2, which is positive 4. You need to get -2 somehow. What can you multiply to 4 that gets you -2? It is -1/2, right? Yep. So your equation is y equals -1/2 x plus 1 x minus 2 x minus 2. Now, does this make sense? Think about it. The leading coefficient is -1/2. It's negative, right? The degree is 3. So when you talk about that, your graph should be following these directions for the end behavior. Because take a look here. When your degree was 3, leading coefficient was negative. It was going up as you went as left. It was going down as you went right. And it follows that here, right? Moving on. Sketch a graph of the following function below. And you're given a table. You were given this, okay? I'm just going to graph it for you, okay? In a different, so you have it. So you have this graph, okay? X plus 4. So there's x-intercept at -4. X-intercept at 1. What is the y-intercept? The y-intercept is product of -1 times 4 times -1 times -1. You might wonder why I wrote this -1 twice. It is because it's being multiplied, it's being power to the 2. If I were to rewrite this, it's basically negative x plus 4 x minus 1 times x minus 1, right? That's what it is. So y-intercept is -4. So -4 is here. Let's say that, okay? What are the x-intercepts? -4, 1, but this one happens twice, right? The degree is negative. Not degree is 3, I meant. The leading coefficient is negative, that's what I meant, negative. So I know that my graph must be doing that, right? So if I were to graph it, it's going to go down, it's going to come somewhere, it's going to go back towards -4. At 1, it's going to bounce back, and then it's going to go on forever. Oh my god, this is the perfect graph that I could have drawn. That is amazing. Okay, see, it makes sense because what did I use? I used my y-intercept, I used my x-intercepts, I used the fact that its degree and is 3 and leading coefficient is negative. Collectively, those information should be enough for you to graph it. Okay, moving on to the next one, and label the roots. These are your roots, right? -4, 1, 1, and this is your y-intercept, -4. You labeled it. Okay. Moving on to the next one. This is recursive and explicit. You guys got this. You just do not need my help for this. Okay, you got this. Question number 10. I think we got this here as well. You got this. I can still help you. The degree is odd. Leading coefficient is positive because the end behavior is like it's normal. As x is going towards -infinity, y is going towards -infinity. As x is going towards positive infinity, y is going towards positive infinity, right? You guys got this. Degree here is even, and because you can also see how many x-intercepts are there, right? There's 3 x-intercepts, so degree is odd. leading coefficient should be negative because it's facing downwards. Yep. Here 1, 2, 3, degree is 3, leading coefficient is negative. You got this. So question number 13, write two random x-intercepts whose vector form of it in its vector form, and the equation must have a y-intercept at negative 12. Okay. Two x-intercepts, I'm just going to name x minus 6, x minus, let's just give me another one, 4. Okay. Right now, my x-intercept is at, my y-intercept is at 24. 6 times negative 4, I mean negative 6 and negative 4, it's at 24. I need to multiply that with something that gets you negative 12. I'm going to solve for a, I get negative 1/2. So my equation is y equals negative 1/2, x minus 6, x minus 4. And that will be the end of this video. If you have any questions, this is my office hours. Otherwise, I'll see you all later.